Hello all, Tin Man here again. I just wanted to do a little experiment that I've done it once before on another forum, but I wanted to do it on our new forum, www.iaec.forumco.com, for all yous that are interested in this sort of thing. Even the beginners that want to get something up and running, come on over. We'll help you out the best we can. Have a look at all our designs. It's only been going for about a week now and it's building up very fast, becoming very popular. So I'm more into the experimenting with different setups, coming up with new circuits and that, as you might know. This I'm going to put on the COP thread that 49 has started up on the forum. It's a discussion on how to measure the COP efficiency of your pulse motors or pulse generators, whatever sort of setup you've got. So what we're going to do, I'm using caps because one, batteries take a long time to get results, and two, batteries are only about 80% efficient, whereas caps are very close to 100. What you put in them is what you'll get out of them, out of a decent well-made cap. These ones are 10,000 microfarads, 63 volts. Like I've mentioned before, they came out of an arc welder. I've got 4 of them. The other one's got LEDs hooked up to it with a resistor that you would have seen in one of my other videos that I was using as a set load. So what we're going to do is we're going to use 2 as our run battery and 1 as our charge battery. However, one of the 2 that we're using for our run battery is going to be flat, and the other one we're going to put our 30.5 volts in. My meter says 30.9, but it's actually only going to be 30.5 because that's a little bit out, because I didn't have a diode on the positive side when I was running my twin back EMF system off here, and it's upset the apple cart in there. So my stupid fault, but things happen. So what I'll do is I'll put our 30 volts in here, get our meter. We'll just check these 2 here. I've got 59 millivolts in that one, and I've got about 600 millivolts in that one. For some reason this one cap recovers really well, gets a bit of recovery voltage. As you can see, 11, 12, 13 millivolts. So it goes up to about 600 and stops anyway. So we've got our 30.6 volts in there. So just keep an eye on that number, 30.6. So what I was saying before with caps, if you hook them up in parallel, one with the 30.6 in it, the other one that's flat. When you do this, you have to hit this on there pretty quick and pretty hard. Try and eliminate as much arcing as you can, because that's just a loss of voltage. So we do that, still get a spark of course. So once we've done that, if we measure our voltage now, we've got 15.1 in that one, and 15.4546 in that one, which is nearly our 30.6 that we started. I lost a little bit in the arcing, but that's not a problem, that's only 0.1 or 2 of a volt. So that's what I was saying about caps sharing their load evenly. Unlike batteries, the higher the voltage gets in a battery, the more it requires to lift it to that extra bit, whereas a cap will share it evenly. So I'll put our 30.6 volts back in there. As you can see on the meter, flatten that one right out, flatten that one out. Put 2 bits of tape on there, 1 bit on there, so you can keep an eye on where the caps are going. So we've got our 2 flat ones. So we're going to put 1 to charge, just to show you that that is actually flat. got 3 millivolts in it, so absolutely nothing. And this one here, it's got 100, 101, 102. This one keeps recovering really good, and then any times you flatten it out, it always comes up to about 0.6 of a volt. So, but not even half a volt, so that's all good. So we've got our 30.6 volts in there. So I'll take that off, turn that off. Now, when we hook these up, I'm going to go from negative to negative. Now the reason we do that is because this one's flat, it means there's the same amount of electrons on the positive side as there is the negative side, which indicates it's flat because there's no current flow. Whereas on this battery we've got none on the positive side and the negative side is full of electrons, because as we know, electron flow is from negative to positive. So what we're going to do now is we'll hook up our charged battery. Like I said, standard SSG circuit. You can try this at home, it will work. Now we're going to hook up our run battery, which, as you know, is our one that's got 30.6 volts in it and 0 volts, or maybe half a volt. Now your negative's going to go on the positive of the flat one, or the one with no current flow in it, and of course our positive to the positive one. Just like that. So what we're going to do now is give her a spin up. Now it won't run for very long on one charged cap, because like I said, they're only 10,000 UF, which is relatively small. Even though they look large, they're designed to put out a lot of amps coming from a welder. And there's 4 of them, like I said, 63 volts, so 6 4s are 24, 240 volts, which is our delivery power here in Australia. Okay, so she's not ticking anymore, so that's, you would think, used all the power out of the caps, correct? Well, not quite. So we're going to hook these back up in series again, negative to positive, and we're going to put our meter on that negative and that positive. We now have 30.7 volts. So that's pretty good. We've just run our pulse motor, and we still have the same amount of power in the combined caps as we started out with. But here's the really neat bit. Where did that come from? 11.9 volts, nearly 12 volts in there. So now, between our 3 caps, we started with our 30.6 volts. If we go and hook all them up in series, you get the positive, get our meter, and put on the 3 caps that are hooked up in series. We now have 42 volts. So, if anyone would like to explain to me where that came from, I'd be more than willing to listen. It's like I showed at the start, caps share their voltage evenly. So unlike batteries, with the first 9 or 10 volts doesn't take much, but the other 2 or 3 volts you've got to put in a 12 volt battery takes a bit more. These don't. What's in them's what's in them. Caps don't hold a surface charge as such. If they say they've got 12 volts in them, they've certainly got 12 volts in them. Oh, and I just shorted that out, so that was pretty smart. Anyway, try again even on this flat cap, or the one that started flat. It has about 15 volts in it. As you can see, it's most certainly in there. So somehow we managed to gain nearly 12 volts in those 3 caps. So this brings me to believe that JB may really be onto something with these pulse motors. I believe you don't get these sort of results with batteries because batteries are only 80% efficient. What that means is if you want 80 amp hours out of the battery, you've got to put 100 amp hours in it. Now the pulse motors condition the batteries to take a high voltage, and the word is that the more you condition them, the more charge you can get out of them, but the easier it is to put the charge in them, like the caps. So as you can see, it ran that light for quite some time. That's actually 24 volt now, so they draw about 4 milliamps on 12 volts. So that's my little experiment for tonight. What I've done, I've set up myself a new board, which I'm going to carry out various experiments on. So by the time I'm finished with it, it'll look like Swiss cheese. The next thing I'm going to do is get my window motor back together, start that up. A lot of guys on the forum want to see how long it'll go on one battery, and how many of the other small batteries I can charge, which means I'll have to put the 12 volt cells that I made out of those batteries, pull them apart, because I charged the other 4 that I had that weren't stuck together. So that's my next project, get the new bearings in that, get it up and running. Just going to make a little shelf here and leave it sit there so we can watch it day by day, week by week, and see how it's going. But yep, just something interesting for you to try. If anyone can explain to me where the extra 12 volts came out of the charged battery, I'll be more than happy to listen. Okay, till next time, cheers from the Tin Man.